Okay, let's do one more section or one more video for section 3.5 and we'll wrap it up, work a problem and go from there. All right, so we've got a good understanding of how this Perroni brake works and how we use it to apply a torque to the motor and how we're able to measure that torque. So let's take that idea and see if we can work a problem involving that. So what we're looking at here is our power of a motor formula. And again, this is power in watts. This is speed of the motor in RPMs. And this is torque of the motor divided by the constant 9.55. All right, so as we look in our textbook, this is on page 53. This is our setup with our Perroni brake. Now we'll point out two things. This particular Perroni brake has 2 gauges, and it's actually more accurate than the one that we use. And just to not to go into a lot of detail on the particulars of this, but this, to get a reading, you subtract one of the gauge values from the other to get more accuracy in the torque that's developed. But as we look at this example 3.4, it says during a Perroni brake test on an electric motor, the spring scales indicate 25 newtons and 5 newtons. Okay, so one's in one direction and the other's in the other direction, and you end up subtracting the two. So this is 25 newtons minus 5 newtons for a total torque output of 20 newtons. The radius is given as 0.1 meters. The RPMs are given as 1700 RPMs. And again, up here at the top, this is how we apply force to this canvas belt. And it is directly applied to this pulley that's mounted on the motor shaft. So to get a reading for this particular situation, it's really pretty simple. Once I have the torque measured, I take power is equal to our speed, which we measured is 1700. Later, we will look at the device that we use to measure motor speed. It's called a strobe tachometer. Then we have the unit for, well, we have 20 newtons for torque. We take that, multiply it by 1700, divide it by 9.55, we end up with 365 watts. 365 watts in horsepower. There are 746 watts per 1 horsepower. And then watts cancel out. We're left with approximately half a horsepower. And that is the output. That is the power output from this particular motor. What I'm showing you here is just another Perroni brake from a different manufacturer. But you can see, they basically operate the same way. This is similar to our Amatrol Perroni brake that we'll be using, where it has the 1 gauge. So that's one look. And let's see. Now, when you step this thing up and you look for something that is able to handle larger motors and those types of things, where you might be looking at something where you needed to measure the output from an automotive motor or something like that, then you get into a whole different world there. Let me pull one of those up and I'll show you that, show you what that looks like. This is showing us a different type of dynamometer. And as you can see, this is in a whole different league than what we're looking at. This is a dyno that actually shows the power output from a PTO shaft, the output from a tractor and all. But anyway, it basically does the same thing in terms of what it measures. you know, it measures the torque produced. And so anyway, just wanted to give you another view of those. And I think we've got this now. We've got this idea of what this power of motor formula looks like and how we can use it.